Hello and welcome to my channel. In this video we want to discuss binomial theorem. You can also call it binomial expansion, and the major area of interest is Pascal triangle. But then what is exactly binomial? Binomial means two-term expression. What do we mean by two-term expression? If we have a plus b, a is what we call the first term, and then b is what we call the second term, and of course when you have first term and second term, that is two terms, and that's what we call two-term expression. All right, so what if we have a plus b plus c? This is the first term, this is the second term, this is the third term, and three-term expression is what we call the trinomial. Of course, two-term expression is what we call the binomial. Bi means two terms expression. Tri means three terms expression, and as the case may be. All right, having understood the basics of this binomial, when we have problem like this, let's set an example. If I have a plus b all squared, what is the implication of this? How do we expand this problem? Of course, if you use the basic algebraic expansion, this means a plus b all maybe into two places. The same way when you have a squared and it will give you a times a. That's the same way when you have this same thing in the bracket squared, it means you can duplicate it. Similarly, if you have it raised to the power of 3, it means this should be duplicated in 3 places. Alright, so how do we solve this problem? Of course, the method of solving this is to use the first term here to multiply by the first term, a times a, and that will give us a squared. Also use this a to multiply by b, a times b, that will give us ab, and again use this first term to multiply by this second term, b times a, and that will give us again ab. Why is it not ba? Is because alphabetically a comes before b, so that's why we're writing ab. Right, plus use this second term to multiply by the second term, b times b, and that will give us b squared. So finally what we have here is a squared plus these two expression terms. If they add up together, ab plus ab, that will give us 2ab, because the coefficient we have here is 1. The coefficient of ab here is 1. The one sum up to 2, and then because they are common, you just pick one of them. Then plus b squared. So this is the result to this expansion. What if when you have it to be like this, maybe a plus b all to the power of 3? Okay, it's the same thing, you just have to duplicate it like this, a plus b into a plus b into a plus b. And of course you see how strenuous this could be, because you need to multiply these two terms first before you use it against this. You multiply these two, and the result you have, you use it against this. And then if you want to go by that, this is what you have. A times a will give us, okay, this result we have is just the same thing. We just write it down, a squared plus 2ab plus b squared, and this result is going to multiply by a plus b. And if we do this mathematics, what is expected of us is to say a squared multiplied by a, and that will give us a to the power of 3. All right, a multiplies by 2ab will give us 2a squared b, plus a multiplied by b squared, that will give us ab squared. We're done with that. Let's use b to multiply the whole of this. So this will be plus b times a squared will give us a squared b, plus b times 2ab will give us 2ab squared, plus b times b squared will give us b to the power of 3. Finally, you will observe that we have like terms here. Of course, you observe that we have a squared b, we have a squared b, and we still have ab squared, and we have ab squared. So this we sum up together, so we have a to the power of 3 plus, if this add up with this particular one, what do we have? That's invisible one here. So if you add up, you have 3a squared b plus, if this add up with this, we have 3 ab squared plus, and then the final one we're having is b cubed. You can see how strenuous. Let's say if you have a plus b to the power of 7, going with this process is strenuous. And then what we need to do at this point is to try another method, which is why we introduce Pascal triangle. So this Pascal triangle will shorten the process. Instead of using this long process, we want to shorten it. Look at how we will apply Pascal triangle in this case. So by Pascal triangle, we will have the first number, which is 1, and this 1 is for when we have a plus b to the power of 0, and then it's just like you having you just assume there is 0 behind or in between. Beside this 1 we have 0 0, so by the time you add up 1 to 0 you have another 1. If you add up 1 to this other 0 you have another 1. You still assume another 0 beside, just like that. This is for when you have the power of 1, a plus b raised to the power of 1. You can use x and y variables again, but the ideal state is just to initiate it by starting with 1, and then you add up 1 plus 1, that will give you 2. You end it with 1, and this is for when you have the expansion of second power. You always start with 1. I think you'll be by now familiar with the formation. 1 plus 3, 2 will give us 3, and 2 plus 1 will give us 3. You also end it with 1, and this is for when we have a plus b to the power of 3. Again, you will have to start it with 1 again. This plus this will give us 4, and then 3 plus 3 is 6. 3 plus 1 is 4, and end it with 1. This is for when you have a plus b to the power of 4. You could actually do this to any number of terms of your choice. This is 5, 1 plus 4, and this is 10. This is 10, and this is 5, then 1, and this is 4, a plus b, all to the power of 5. So we can continually do this to any term we want. And this is a triangular rather, is a triangular arrays of number, arrangement of number. All right. Say you want to look for the expansion of to the power of 6. I could easily start with 1. 1 plus 5 will give us 6, and 5 plus 10 will give us 15. 10 plus 10 will give us 20. 10 plus 5 will also give us 15. 5 plus 1 will give us 6, and it also ended to 1. This is for a plus b, all to the power of 6. All right. So now we've gotten to this point. We understood how the Pascal triangle is being organized. Let's use through Pascal triangle to solve those same problems we've solved earlier, which the first one was the expansion for a plus b all squared. Of course, the result we had was a squared plus 2ab plus b squared. Let's see if we can still use Pascal triangle to get the same answer. Of course, for the expansion to the power of 2, this is the coefficients. So let's fetch out the coefficients. I'm solving using Pascal triangle now. I'll write down the coefficient, which is 1, 2, 1. This is the coefficient for when we have the power of 2. Alright, so how do we apply it? This first one you're having here is for the coefficient of this first term, and this one is for the second term. So the first thing that we need to do is to multiply this 1 by this a and raise it to the power of 2. So 1 times a will give us a, alright, to the power of this 2, plus the next thing we need to do is to use this 2 to multiply by these two terms, 2 times ab, and that will be 2ab, plus then this one is for this last one, as I said earlier. 1 times b is b, all to the power of 2. What did you notice? You observe that the decrement we have for a, as a value, the power of a is decreasing, so the power of b is increasing. All right, so let's check out for the second problems we solved. The second problem we solved, which is a plus b all to the power of 3. How can we use Pascal triangle to get the same answer so that you can compare with it. So solution, what do we need to do? For this 3, the expansion, the coefficient we had was 1, 3, 3, 1. You can confirm that when you have to the power of 3, you have 1, 3, 3, 1. So how do we use this to get this value? Of course, you use 1 to multiply by this a, so we have a to the power of 3 plus this 3 will multiply this 2, so we have 3ab plus this 3 will multiply this 2 again, we have 3ab. I'm just using the short possible way you can be able to flow with it, plus the last one is 1 times b, which is b to the power of 3. But I told you something, that the power of a decreases as the power of b increases. So if we have 3 here, here will become 2 and here will become 1. Similarly, if we have 3 here, here will become 2 and here will become 1. So cross check this result with what we had earlier. You will see that Pascal triangle is very, very simple. One line expression, you'll be able to get the answer. So in the next video, we're going to solve more problems using Pascal triangle. If you've not subscribed to my YouTube channel, please hit the subscribe button and turn on the notification bell so that by the time I upload new video, you get notified. And please share this video. Thank you and stay tuned.